solve for x. And here we have the logarithm of x is equal to the logarithm of x plus 8 minus the logarithm of 2. Now looking at this given expression, we see that our x is trapped within the argument of the logarithms. So we want to get rid of these logs in order to solve for x, but we're prevented from applying the inverse property immediately because we have the difference of two logarithms on the right-hand side. So how can we fix this? Well, let's recall the quotient rule from those algebraic properties of logarithms. We want to recall that if we have, say, the logarithm of a minus the logarithm of b, we can rewrite this as the quotient, the logarithms of a divided by b. So that's where we're going to begin. We are going to start our solving process here by rewriting this given logarithmic expression. So the left-hand side will stay as it is. This is still log of x, but this is now equal to the log of, we have x plus 8 divided by 2. Beautiful! So now we have one logarithm on the left-hand side and one logarithm on the right-hand side. How can we get rid of these logarithms? Well, keep in mind, while it doesn't appear that we have a base here, remember that when there is no clear base, this is equivalent to saying log base 10 of x is equal to log base 10 of x plus 8 divided by 2. So now that I have identified what this base is, we are ready to apply the inverse property. So we are going to apply the exponential function base 10 to both sides. So we apply the exponential base 10 to both sides of this equation to remove the logarithm base 10. And let's give ourselves a little bit more room here. So applying the exponential base 10, this expression now becomes 10 raised to the log base 10 of x is equal to the exponential base 10 raised to the logarithm base 10 of x plus 8 divided by 2. And so now, because the exponential base 10 is the inverse of the logarithm base 10, these are going to undo the effects of each other on both sides of this expression, leaving us with x is equal to x plus 8 divided by 2. Beautiful! So this looks like a much more familiar algebraic expression. So to solve for x here, we want to remove this fraction on the right-hand side. So to do that, I'm going to multiply both sides of this equation by 2. So we can see on the right-hand side, 2 divided by 2 cancels itself out to 1, leaving us with 2x is equal to x plus 8. So now to solve for x here, we want to bring all of the x terms to one side. So we'll do that by subtracting this x from both sides of this equation. So we can see on the right-hand side, x minus x cancels itself out to 0, leaving us with 2x minus x is equal to 8. And so there you have it. This is our beautiful final answer. Now, for fun, because math is fun, let's make sure that this is, in fact, the correct answer. So we need to check our work. So in order to check that x equals 8 is, in fact, the solution, we're going to plug this back into the original expression. So what I'm going to do is use our simplified original expression here to evaluate when x is when x is equal to 8. So what we're asking ourselves is the logarithm base 10 of 8, is this really equal to the logarithm base 10 of 8 plus 8 divided by 2. So I don't know, let's find out. So our left-hand side is as simplified as it can be, so we're only worrying about the right-hand side. So we have the log base 10 of 8 plus 8, which is 16. So we have 16 divided by 2, and we can simplify this to log base 10 of 8. Woohoo! So we have a shown equivalence, and we have officially confirmed that yes, x equals 8 is the beautiful final answer.